All right, let's go ahead and open up this mini quiz 8, see what it looks like. It's due a week from today. You're going to be doing some real physics on this. And it's good. I mean, you've been doing real physics all along. Okay, so here you go. Ho, how long does it take for the eye to pick up the... Okay, so all of these little data points are in that cool little video, all right? All right, so now we're going to calculate the impulse on the ball, all right? Okay, so assuming its initial speed is 0, okay, and its final speed is 120 miles an hour in meters per second. The mass of the tennis ball is approximately 0.06 kilograms. Okay, so the impulse. What is the impulse? So that's what we've got to calculate here. And we know that the impulse is equal to the mass times the change in speed or change in velocity. And I'm going to hold you to the change in velocity, okay? So velocity final minus velocity initial. That's what the impulse is. So we know the mass is 0.06 kilograms. Okay. And we know the final velocity is 120 miles per hour, but we've got to change that to meters per second. And you know how to do that, right? Don't forget, just multiply by 0.447. Okay. And you've got it, all right? And then the final velocity, or then the initial velocity was 0. And it actually is. And it actually is meters per second, 0 meters per 0 miles per hour, doesn't matter. Okay? So you plug those numbers into there. Do the subtraction first, and then do the multiplication. Or if you have a calculator like mine, you can just plug it in so it looks like this. Times the meters per second, final velocity minus 0. And since you're doing minus 0, it's pretty simple. Okay, now we're going to get a little bit more difficult as we move along. So let's go to the next. What's the next problem say? All right, so there's how you find the impulse. Now, the Serena's contact is in contact with the ball for 0.05 seconds, which they said in the video. What is the average force she exerts? She hits the ball during her serve. This calculation is in newtons. So this is the Serena problem. Okay, so this is the Serena problem. So remember, the impulse also equals not only this mass, the change in momentum, the impulse also equals the average force times the time. Well, you found this one from up here. Delta t, the change in time, is equal to 0.005 seconds. 5 milliseconds. That's all it should. Whack. Okay, the sound lasts longer than the actual thing. All right. So the number you got before, so you take that number, that answer that you got before, and divide it by 0.005, and that'll give you the average force. It's huge. It'll be pretty darn big. Okay? Okay, now I ask you how many, so some of you may not understand the Newton, or the Newton's thing doesn't mean anything to you. So I said, how many pounds is that? Okay, so for question 5, go to Google, go ask Google, say, I've got so many newtons to pounds. And Google will tell you. You can also multiply by, I think I have that number here. Or did I throw it away? Dang, I threw my notes away on this. Can't believe I did that. All right. Well, I'll show you. I'll show you. 1 Newton, let's go to 1 Newton is how many pounds? So you go, oh, yes. So you're going to multiply by 0.22489. And that'll give you the pounds of force. It'll bring it down quite a bit. I was looking for my calculator. Oh, here's one. Sorry, I'm kind of wasting your time here a little bit because I did a little bit different. I just want to make sure this is correct. All right, before we move on. Okay, so. Oh, and I got a bullshit. I can only use my calculator. All right, so that's how you do. Just multiply whatever you got in newtons by this, and that will give you, by this number, and that will give you the pounds. Okay? Let's see what else we got here. What is the acceleration of the tennis ball? Oh, that's cool. Look what I'm making you do there. Okay, so on problem 6, what's the acceleration of the tennis ball? Let's take a look. You know, you found the force in newtons. So you take the force in newtons, you found that. What does force equal? That average force is equal to the mass of the tennis ball times the acceleration. You know the mass of the tennis ball is 0.06. How do you solve this little equation here? You know this number, and you know this number. You want to get this guy. Think you can do that. All right, we're going to stop here, and then we'll look at the second problem, which is a ball hitting a bat, which is really cool.